Homework 5 is about quadratic equations and solving quadratic equations. Now, quadratic equations have many different ways to solve them, and so in the Homework 5, we ask you to do it in 3 different ways. Number 1, by factoring. Number 2, by the quadratic formula. And number 3, by completing the square, or the square root property. Now we're going to start by factoring. Now factoring, the way you need to do it is to factor it into two binomials and then to solve each one individually. Now the first thing you have to do with pretty much every quadratic equation, well maybe not every, but most quadratic equations, is to set the entire thing equal to 0. So in this one over here, you've got an equals 8, so the way to get that equal to 0 is to simply get rid of the 8. And the way you get rid of the 8 is by subtracting 8 from this side, which means you got to subtract 8 from this side. So it means you got the 3x squared minus 2x, remember they're different variables so they can't be combined, minus 8 equals 0. Now you can factor into two binomials. Since we've got a 3x squared over here, the only way to get that in with the first two terms is to use a 3x and an x, because that's the only thing, those are the only two terms, both containing x's, that are going to get you to 3x squared. Now, because this is a negative, it means we're going to have one plus sign and one negative sign, which means we're going to need two numbers that multiply up to negative 8 and add up to negative 2. However, it's important to realize that whatever is over here is going to get counted double, because remember, when you FOIL it, the outer means this gets multiplied by this for the middle term. Now, of course, when you're talking about, so you really need to do a little bit of trial and error to figure it out. Now, of course, multiplying up to 8, there are only two possibilities, 4 and 2, or 8 and 1. And 8 and 1 I don't think is going to work. And if you do a little trial and error, you realize the only way to do it, for this to be a negative 2, is if you make this into a negative 2, and this into a positive 4. And the reason why that works is because, well, they multiply up to negative 8, because it's 4 and negative 2, which is negative 8. And they add up to negative 2 because the one over here counts 3 times because it's opposite the 3x. So negative 2 times 3x is negative 6x, and then the inner would be positive 4x. So overall, you'd get negative 2x, and that's why they work. Of course, you could check it to make sure it works. 3x plus 4 times x minus 2. If you FOIL it out, you get 3x times x, which is 3x squared. Outer is negative 6x, inner is positive 4x, and last is negative 8. And these two combined, the middle two combine to get this, which is of course the same thing as we had originally, so it checks out. Once you have this, now you can divide them. Each side is equal to 0. Since anything multiplied by 0 equals 0, the whole expression becomes 0 if either term is 0. So each one is equal to 0. 3x plus 4 equals 0, and x minus 2 equals 0. And so for this, you can solve it like you would any other equation. Subtract 4 from each side, and you've got 3x equals negative 4. Then divide each side by 3, and you've got x equals negative 4 over 3. That's one answer. Sorry, I didn't have room for it on the left side. And on this side, you just add 2 to each side, and you have x equals 2. So our two answers are x equals 2 and x equals negative 4/3. Both of them, if you plug it back in, I'm not going to do it, but if you plug it back in, both of them will work to solve the problem. Either of these will work. Okay, let's try number 2. Number 2 is similar. X squared minus 3x minus 10 equals 0. This is actually a little simpler. Well, it's already equal to 0. So use two binomials. Since it's x squared, you've got x and x. Now this is a negative number, which means the signs have to be split. And we need two numbers that add up to negative 3 and multiply up to negative 10. And again, if you do a little bit of trial and error, you'll realize pretty quickly that 5 and 2 work. Negative 5 and positive 2 work. And so you split that because negative 5 and positive 2 add up to negative 3 and multiply up to negative 10. So you got x plus 2 equals 0, x minus 5 equals 0, and on this side you've got x equals negative 2, and on this side x equals 5. If you want to check it just to make sure, we didn't do this last time, but we'll do it now. The original equation was x squared minus 3x minus 10 equals 0. So let's try negative 2 first. negative 2 squared minus 3 times negative 2 minus 10 equals 0. Negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. Negative 3 times negative 2 is positive 6. Minus 10 equals 0. And of course that works because 4 plus 6 is 10. Minus 10 is 0. And now we can try it with 5. 5 squared minus 3 times 5 minus 10 equals 0. 5 squared is 25. Minus 15 minus 10 equals 0, which of course is true. Numbers 3 and 4 ask you to solve using the square root property. And the square root property is simply based on the idea that if you take the square root of an x squared, it will give you x. So you can use that method to solve the problem. When it works, this is actually the simplest method to do it. The way you do this is very simple. 3x squared minus 3x squared equals 27. So you would need to isolate the x squared, and of course, like any other equation, divide each side by 3 to isolate the x squared. Equals 9. Now you take the square root of x squared, that's going to give you just plain x. So whatever you do to one side, you got to do to the other side. And the answer here, well, the square root of 9 is 3, but remember it's plus or minus 3. It could be positive 3 or negative 3, because anything that is a negative number multiplied by itself will give you a positive number. So the answer is plus or minus 3. So there are actually two answers. One is x equals 3, and the other is x equals negative 3. If you write plus or minus 3, that's fine also. But if you just write 3, you don't get full credit because you haven't completely answered the question. Okay, next one. Here is also a similar idea. In order to, there are really a couple of ways to solve this. You can multiply the whole thing out, and like we did before. You can multiply this out in two binomials and then combine everything, and you can do it that way. But a much simpler way to do it is to get rid of this exponent, get rid of this squared. How do you do that? Well, very simple. Take the square root of this whole side, and then you're left with 3x plus 2. And of course, whatever you do to this side, you do to that side too. So you got the square root of 9. The only thing is that you have two different possibilities. You've got positive 3 or negative 3, as we discussed. So you've got two different answers, and just like most quadratic equations, you're going to get two answers anyway. So here, you've got two different possible equations. You've got 3x plus 2 equals positive 3, and you've got 3x plus 2 equals negative 3. And we can solve for each one of them separately. So on the left side, subtract 2 from each side. So you've got 3x equals 1. Divide each side by 3 to isolate the x, and you've got x equals 1 over 3. That's one answer. And on the other side, we can subtract 2 from each side, and we've got 3x equals negative 5. And again, divide each side by 3, and we've got x equals negative 5 thirds. Either one, of course, is a correct answer. If we plugged it back in, I'm not going to do that, but if you plugged it back in, you would get the correct answer as well. In case you're curious, by the way, just to show you, I'll use a different color, but just to show you that it would work the other way too. Let's say we wanted to do it the long way. We had 3x plus 2 squared equals 9. So we could multiply it out. We could FOIL it. We could make this 3x plus 2 times 3x plus 2, which is the same thing as 3x plus 2 squared. So 3x times 3x is 9x squared. Outer is positive 6x, and inner is positive 6x again, so we'll make it plus 12x plus 4 equals 9. And then to set it equal to 0, well, it would work, but it would, well, let's set it equal to 0 by subtracting 9 from each side. We've got 9x squared plus 12x minus 5 equals 0. And then if you'd factor it, well, it would be more complicated because you'd have to, I imagine, get 3x on this side and 3x on this side to multiply up to 9x. And then you'd need a 5 and a 1 in order to multiply up to 5. And this is positive, so we'll make the positive get the 5, and we'll make the negative get the 1. And does that work? Let's see. 3x times 3x is 9x squared. Good. Okay, 12x is positive 15x minus 3, so the middle term works also, and the last term also works. So this actually does work, and then of course you'd set this side equal to 0, 3x plus 5 equals 0, and this 3x minus 1 equals 0, and if you solve for this, you subtract 5 from each side, so you get, and then divide by 3, so you get x equals negative 5/3, and on this side you add 1 to each side, so you get x equals 1/3, which is of course the exact same answer as we got in using the other method. And the third method by which to solve a quadratic equation, or the third method that we're going to learn, is the quadratic formula. Sometimes factoring just simply doesn't work. Sometimes the other method, the square root method, simply doesn't work. So you need to remember the quadratic formula, and this will always work, but it's just a little bit more complicated. And unfortunately, you just have to memorize this. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant, in other words, the regular number, assuming that everything is equal to 0. So if we wanted to use the quadratic formula for the first one, a would be 1, because there is no coefficient of the x squared, which means it's 1. The b would be 8, and the c would be 15. So let's use the quadratic formula. Negative b, or negative 8, plus or minus the square root of b squared, which is negative 8 squared, minus 4ac, 4 times 1 times 15, all over 2 times 1, because a is 1. And let's execute this. So we've got x equals negative 8, plus or minus the square root of negative 8 squared is positive 64, minus 4 times 15, which is 60, all over 2. And 64 minus 60 we can change to 4. And of course the square root of 4 is 2. It's plus or minus 2, but it's already plus or minus, so you don't have to put another plus or minus there. So it's x equals negative 8 plus or minus 2 divided by 2. So you've got two different possibilities. You've got negative 8 plus 2 over 2, and you've got negative 8 minus 2 over 2. Negative 8 plus 2 is negative 6 over 2, which is negative 3, and negative 8 minus 2 over 2 is negative 10 over 2, which is negative 5. So here are our two answers, negative 3 and negative 5. And by the way, this could have been factored also. If you notice, you could have done two binomials, 8 and 15, which is 5 and 3. So x plus 5, x plus 3 equals 0. X plus 5 equals 0, x plus 3 equals 0, and of course subtract 5 from each side, x is negative 5, subtract 3 from each side, x is negative 3, which gives you the same answers. So you see, it's like in this example down here, I don't think it's possible to factor, so therefore you have no choice but to use the quadratic formula. So let's use the quadratic formula. It's equal to 0, so we can establish that a is the coefficient of the x squared, b is the coefficient of the x, not 3, but negative 3, important distinction, and c is negative 4. So we've got x equals negative b, which is negative negative 3, which is positive 3, plus or minus the square root of b squared, negative 3 squared, which is positive 9, minus 4 times 3, which is a, times negative 4, all over 2 times 3, which is 6. So x equals 3 plus or minus the square root of, well, let's see, what's negative 4 times 3 is negative 12, times negative 4 is positive 48. So negative 4 times negative 4 is 16, 16 times 3 is 48. Either way, you get positive 48. So you have 9 plus 48, which is 57. Square root of 57 over 6. Now you can break this down. Let's see. Can you break down 57 into something that is a perfect square? And the answer is I don't think you can. 57 only goes into 19 and 3 are the only roots of 57, and neither of them are perfect squares. So there's pretty much nothing more you could do here, and so your answer is this: 3 plus root 57 divided by 6, or 3 minus root 57 divided by 6. Either way, that's the best answer that you can come up with.